We continue with the penultimate part of our analysis of brain electrical activity in elite Rubik's Cube players based on the findings of Zare et al. 2025. But before we dive into the results, we need to understand one fundamental and very important concept, pairwise correlation. And we'll also briefly recall the cognitive tasks used in the study, since we already explained them before, and there are video links in the description box. The tasks are Tower of London, TOL, measuring planning and problem solving. Memory task, measuring the ability to retain and retrieve information. Judgment of line, angle, and position, JLAP, measuring visuospatial perception. Finger movement sequence, FMS, measuring motor speed and precision. All of these tasks are directly related to solving the Rubik's Cube, because it is an activity that brings together every cognitive function. Planning, TOL, memory, MM, visual perception, JLAP, and finger movement, FMS, the entire brain is at work. Now let's return to the concept of pairwise correlation. This analytical method gives us a sharper view of how cognitive tasks are connected and interact within the brain. Instead of looking at the full picture all at once, we go step by step and compare every two tasks on their own in order to uncover the true relationship between them. To simplify the idea further, imagine this everyday example. You are studying 3 subjects, mathematics, physics, and language, and you want to know whether your performance in one subject affects your performance in another. What do? You compare them pair by pair. First, let's compare mathematics with physics. Next, we compare mathematics with language. And finally, we compare physics with language. For example, if you find that whenever you are strong in mathematics, you are also strong in physics, we say there is a strong correlation between them. But you might find that language has little to do with mathematics. Here the correlation is weak or even absent. And this brings us to the core idea. Pairwise correlation simply means we compare each pair on its own, so we can understand its relationship precisely without mixing everything together at once. And this is exactly the approach the researchers used in this study. They compared each cognitive task with every other task, one by one, to reveal how they resemble each other and how they influence one another inside the brain. And in the next part, we'll be looking at the surprising results of these analyses.